We will now listen to the opening lecture, which this year we asked Professor Carlos Ferrater to give you. He is a professor at the Technical University, and the title of his presentation is Engineering and Architecture, which is a timely topic and very fashionable today. So, Mr. Ferrater, the floor is yours. Thank you. Good morning, dear Rector, dear academic authorities, ladies and gentlemen. When the Rector, Mr. Antoni Giro, granted me the honor of asking me to give this opening lecture, I was very much aware of the dissociation that we've witnessed lately between architects and engineers in the Technical University. This separation has been worsened by the intent by the Spanish government of approving a new law on professional services that, rather than bridging the gap between the two professions, it seems it tries to confront them. That is why I decided, with the collaboration of Alberto Peñín, a professor that I've been working together for many years, teaching in a joint professorship called Cátedra Blanca, I decided, as I said, to devote this opening lecture to discussing the fruitful relation that we've witnessed in the modern history between engineers and architects, a relation that has implied the greatest technological and constructive revolution ever. I believe that history has managed to prove that that has been and is indeed possible. So, by unveiling the false alleged contraposition between architects and engineers. And without any further ado, here is my lecture entitled Engineering and Architecture. Design is created by many people. The myth by means of which technology is the result of a predetermined logic is not true, but rather it is a consequence of a complex process, analyzing a great deal of information to end up being able to choose. So what matters is people and their talents. Peter Rice, an Irish engineer, in his book entitled An Engineer Imagines, described the constructive process at the Centre Pompidou, which he shared with the architects, the authors of the project, the workers that took part in the process, the companies that were involved, and some member of the jury in the tender, like the famous builder Jean Prouvé. So this joint procedure doesn't talk to us about a particular way of doing things, but it's actually describing the only way of confronting construction in the second half of the 20th century, the complexity in its technological aspects, construction-wise, also the instruments, the content, without neglecting regulations, turns constructing into an act that can no longer be individual. Project is an open process, and it is not linear. It is a community project, it's a joint project, and that is why this community concept gains weight. University, as it means community, seems to be an ideal place to promote and transfer this condition of the construction as a joint act. The partnering between the architectural school and the Technical University in 1973 was a landmark in the relation between the architecture and engineering studies as a symptom of convergence between the two professions. That is why, and due to my personal experience in dealing with many engineers, especially road engineers, that is why today I would like to present you with a discourse about what I consider to be a passionate relation between engineers and architects through the modern era. And we should begin this narration in the beginning of the Renaissance, probably the most naked in the sense of what's superficial, so in the sense that it's pure and more authentic. So before this splendorous era, the guild system had all the construction knowledge gained by the masters. They would draft the working drawings, and Brunelleschi, when he won the tender for the dome at Santa Maria del Fiore, he joined together structural with construction structure, giving rise to the first modern architect figure, or at least that's what we know. Maybe he could have been the first modern engineer. The fantastic dome at Santa Maria del Fiore supposed a breakthrough, the first one in 13 centuries, ever since the Agrippa Pantheon, 43 meters long in span. So it was the beginning of a project anticipating construction, the suppression of horizontal effort without forgetting the incorporation of a flashlight as a light mechanism, turned a device providing it with structural stability. So it was a way of fine-tuning mass construction, like in the Pantheon. Brunelleschi opened a way to technical specialization, and it caused the incremental separation between constructor architects and essayist writers architects, as Alberti. It's not about formalizing structure, but structuring form, rather, he said. After the Baroque, and while Ledoux and Boulez imagined visionary project, Piranesi was devising his Carcieri. The century of light turned into an objectivation of construction. So Duran was the beginning by exploding positivism and applying the concept of economy that was part of the Industrial Revolution before. And in France, Napoleon created the engineering corps, a profession clearly linked to military wit, with the machines by Leonardo da Vinci, war machines, but thinking especially in the building and construction of infrastructures. That is when and why the École Polytechnique was born, that remained. And when we had the appearance of iron as a material linked to structure, then engineering started to become a liberal profession. It was not always linked to the government and institution. Technical specialization then became intrinsic to construction, and it doesn't come only from a treaty, from writing from an essay. So it opened up a whole range of possibilities. This tender in 1418 in Florence, we can move to 1851 in London, when Joseph Paxton won the tender to build the Crystal Palace, 70,000 square meters surface. Standardization decided the winner of a project where technical purity led to a structural decision. The serialization as a constructive reasoning intervened in the process, in what authors like Kenneth Frampton describe as the fact that a tectonic concept and a rational work don't have to match. The Crystal Palace paradigm of the Victorian architecture, that is where we see that iron columns have their diameter, even if the requests were different. The idea was to get to standardized solution that would allow an easy assembly and a cheap one. It was the time of universal expositions, great technological window cases. It's still to be seen the story that links material and structure. That is when in Paris, Universal Exposition 1889, we could see cast iron and rivets in the mythic gallery of the machines. And then decades later, we saw that in the concrete membranes by Maillard in Brussels, 1958. We were surprised by cables, and in Montreal, 1967, we could see the geodesic domes by Buckminster Fuller and the textile structures by Frey Otto, with those assembled knots by Georg Schlag, German engineer that I will refer to later on. The Osaka exposition in the 70s with the pneumatic structures, like in the pavilion in the US by David Geiger that then turned into the idea of building a stadium 120 meters long in span for the Olympics in Korea 1988. So it was a path that takes us from the Renaissance to this progressive segregation, separation between the construction knowledge that both professions share, both engineers and architects. And in the 19th century, architecture becomes absorbed in the academia, and then engineering begins to be the backbone of innovation and technological development. And in Barcelona, indeed, we have a very close example. What is it we're most interested in? The structural boldness of the scaffold by Joan Torres, or the sculpture composition of the monument to Columbus by Gaeta Boigas Monrabat. So the engineers would explore a new world, traction, whereas architects, as Javier Manterola used to say, he said that in an interview in our academic newsletter, Palimpsestre, the architect thinks in stone terms, in a world of compression, and that inertia is shared by many architects even today. And that takes us a few years later. Even despite this technological rhetoric, the modern movement increased the separation between conception and construction, even if there was this enthusiasm, naive maybe, if you wish, of those new techniques by the heroic generation of architects that would represent that, would turn technology into a myth. The historian, critic Rainer Banham, in his work Theory and Design in the Era of Machinery, deepens into the inability of the modern movement when capturing the skills of the new technology by believing more in the typology and understanding the technique more like an operational tool. Only Buckminster Fuller would be an exception to that years later, the avant-garde of the projects of the time. It's been frequent in history, this certain inertia stopping the expression of technical breakthroughs. We have the Iron Bridge by Coke-Brookdale that followed the guidelines of construction in stone, so not making the most of iron, and whilst the majority of architects in the avant-garde movement would be an example, like German Mies van der Rohe, it would dream of industrialization of construction as the main problem in architecture, and he would even say only the skyscrapers in constructions are bold enough when we see their structure, and that is only when we see the effect of the slender steel skeleton. As a new Nietzschean man, orthogonal in heart and soul, he defined Ludwig Hilbersheimer in a building in Chicago by the German architect Mies, found this sort of new nudity in his architecture. So it's like the means becomes the way the underlying technique of the form of the shape anticipates the aesthetic of the technique. Le Corbusier would signal that l'important c'est le choix. So what matters is the choice, giving to the world of construction the decision of the construction method, so keeping to itself the moral burden of transferring the method to these formalizations. So construction is what matters for both professions, but if for me it's perfection, for Le Corbusier the important thing about construction is the man's intervention. In the years after the Second World War, we saw the coexistence of architecture and technological engineering, so technological with Le Corbusier, with the two hands intertwined. That is the way in which he expressed that he was conscious of that need. Many authors say that the apocalyptic conclusion of the Second World War was the end, the equivalent to the end of positivism, by means of which technique incorporated transcendent meaning that would then lighten the modern world. There will be a third generation of that movement, caring more about the city, mankind, art, and nature. One of the architects of this third generation, identified by Gideon John Utzon, he would acknowledge that he could practice what the visionaries had warned. The modern techniques had actually given us a beautiful tool, he used to say. So opening the door to an involuntary dissociation of the modern movement to try to find a convergence. On the one hand, we have the interest by architects on technological breakthroughs, and we have many more engineers that would turn to humanistic profiles, many of them working in genres like poetry, art, philosophy, and we have authors of texts, relevant texts, that actually entered into the field of humanities, and that is a tradition that we still see. In the field of new structures, we have new figures that we could call project-based engineers. Maybe we can refer to Pierluigi Nervi with his nerve-like structures that stem from his research on pre-stressed concrete by Fressinet, 1928, and he has executed the Palazzo del Lavoro in Torino, 1961, or maybe we can mention Riccardo Morandi, maybe the first deconstructivist engineer before we actually even had that term, with the underground hall at the Valentino Park built in Torino, 1960, or Felix Candela with his thin concrete membranes reproducing this orthodox geometries that gave us his text entitled Toward a Philosophy of Structures, a text that really was very important for me in my career. Or Eladio Dieste with his vaults of ceramic pieces, experimenting like Guastavino, that actually became a patent. And we cannot forget the contribution by Eduardo Torroja. He sophisticated concrete building, and beyond the problem of flowing at the Fronton de Recoletos, he actually gave us as a legacy texts like raison d'etre of structural typologies.
Torroja said that only imagination cannot achieve a great work because you also need reason, and you can also achieve it either by only deduction, which is only logic and determinism. So there is a necessary convergence between two contributions that had to complement each other. And that leads us to analyze the cases of reciprocal influences between architects and engineers. Le Reculé, who had a great influence on Le Corbusier because of his research of natural structures, he was also fascinated by the latter. Pont Cavary by Eiffel at the end of the 19th century, or the relationship that was created between Konrad Wachsmann and Walter Gropius to prefabricate houses, to build them in 7 days, or the engineer Fazlou Khan, who in the 60s worked with rigid covers and roofs that were hung from curved cable up to 300 meters of length and span, and in 1977 he created a bitubular structure for buildings that some was then used then in multiple projects. Carlos Fernández Casado said in his text Architecture of the Engineer, the release of the obsession by calculation thanks to the use of new tools such as calculators, and this free engineer can now establish common areas with architecture in order to achieve a more efficient collaboration and also reinvent the essence of profession. Javier Manterola, now the author of the study on Carlos Fernández Casado, conveyed a more pragmatic position after a period of collaboration with architects such as Javier Sáenz de Oiza, Rafael Moeo, or Vázquez Molezún. He focused his interest on his own discipline, particularly the construction of bridges. Aquellos que vencen al diablo, those who defeat the devil. And he admired like the Firth of Forth in Scotland, bringing together technical achievement with the transformation of spaces that led us to signify cases of a fruitful relationship between engineers and architects, such as the Pont de Millau in 2004, between Michel Virguleux and Norman Foster, who also created another one of his best buildings at the airport of Stansted in 1991 with the engineering company over Arup. And how can we understand the best works by Louis Kahn without the contributions by the engineer Auguste Commandant, who also protested the lack of recognitions that he had in the work of Louis Kahn, works such as the Phillips Exeter Library, 1972, or the Kimball Museum, amongst others, in which Commandant conceived a structural system of cycloid arches in a cross-sectional direction, allowing the entry of zenithal light. They wouldn't have been possible, the achievements of Louis Sullivan in the auditorium building in Chicago in 1889, in the highest, at the time, the highest building of the world, and first lighted with electrical light, without the collaboration of Dagmar Adler, both in structural aspects and also acoustic ones. There are so many works that have been created in collaboration between architects and engineers and have become masterworks in the 20th century. Let's briefly analyze the role of engineering companies that have been a substantial part of the large constructions in the last decades. And we need to start with Over Arup, that always claims a convergence with the architects with which they work. In their texts that are not numerous but very intense, Arup brings down the myth according to which creativity is an individual issue. His belonging to AA in the 50s was the root of the first collaborations with very creative architectural studies, but that didn't have much work back then, such as Aldo Van Eyck, Summerson, Smithson, or the Tecton study of Bertil Lubetkin, with whom he built the extraordinary Penguin area in the London Zoo in 1934. Arup shared with Lubetkin the belief that the modern movement considered the structural expression intrinsically virtuous and aesthetically superior, whereas for them the challenge was going beyond the structural criterion and including social considerations. And this led to the belief of Arup in architecture that does not necessitate so much calculations that go belong, which is assumable. Like Kenneth Frampton said, it seems true that, with the exception of some commissions of small dimension or prestige, the architect will not have many occasions to control the realization of the project. And we're going to show an historical episode. When John Hudson created the spheric solution for the false domes of Sydney that had been drawn by Raphael Moneo, by the way, who worked in his study. Well, they also were the years of work of a very young engineer, Peter Rice, that saved the architect from the troubles that he had gone into in the tender. And then Peter Rice, years later, now a very experimented engineer, achieved, in words of Renzo Piano, the implementation of a constructive solution, the almost ideological incorporation of cast iron in the in the purest Parisian tradition, including leading to a cascade of decisions from the choice of systems such as the Gerberet that had been already applied by the German engineer Gerber in the 19th century, and the materialization of proposals by Archie Gram in the prelude of high tech. He also surprised us with his structural solution in the airport of Kansai in 1994, and so some of the most emblematic works in the 20th century were thanks to the combination of architects and engineers. We have two derivatives in the fields of architecture and engineering that have altered this savoir-faire in the last few years. In the case of engineering companies, very often we have seen a corporate rhetoric that has developed mainly in the Anglo-Saxon world because of franchises that are led by multiple partners that have equal ability of commercial management with technical qualification. The American architect Owings, associated with Skidmore and Merrill, who in 1936 created the Studio Somme, and that have left us with a great legacy of buildings, amongst which I would like to highlight the Sears Tower, said that as some grew, it became more rigid, and I wondered what they had become. Of course, there were no designers, but corporate people, financial promoters, and business people. Carlos Fernández Casado talked about two dangers in his profession, particularly in large engineering companies. The civil servant engineer who things in terms of the past that enabled him to get to his position, and the businessman engineer who chooses their projects not because of professional values, but because of the expectation of making money. In Spain, we have had two engineers who have become government presidents, Sagasta and Calvo Sotelo. In England, in Westminster Cathedral, together with Nelson and other national heroes, engineers such as Brunel, Telford, or Stevenson are buried. And as a positive factor, we have to highlight that also engineers have built and headed infrastructural and networks and the planning of the territories. And let's not forget that the rational and utopian Barcelona, in which we as architects see ourselves reflected, was planned by engineer Ildefons Cerdà. And the negative aspect in the field of architecture is that technological breakthroughs, but also the ability of companies to build, despite everything, any form, any shape, however complex, and together with the ambitions of administrations to build symbols that bring the cities into the global map, and also the need of the media to make them, to publicize them, has meant in the last few decades for prestigious architects formal adventures in which the iconic value and calligraphy have been the main characters of interventions of buildings, the main mission of which was to create astonishment, surprise, admiration, even if for a very short period of time, forgetting that the aim of architecture is to persist, to survive in time. And that is never ephemeral. But going back to our narration, Agustí Obiol, a specialized architect, he was specialized in structural calculation, following a tradition in this city, such as Marguerite Bouchardet and Ruffau, told us that the appearance of new technologies, when the first qualitative leap takes place, the decomposition in sufficiently small intervals so that each of them can be described as a simple function until it becomes a condition of continuity in the transition between intervals. That is an extraordinary working tool for engineers and architects, and with Juan Calvo, road engineer who worked in Madrid. And thanks to him, we have been able to use in several projects in our company, in our study, trying to implement this underlying spirit combining architecture and engineer as the base and the support of the project. In the Media Pro building in Diagonal Avenue, the first conceptual embryo that was submitted to the tender, and he's a very clear example of this urban and programmatic condition. It's sometimes difficult to understand at first glance which is the actual structural behavior despite the logic of its first design. I think that the collaboration of our company with Juan Calvo, who was the disciple of that great German engineer Jörg Schleich, who is the author of such important works such as the Palau de Gel of Munich, the ice rink in Munich, and that we have mentioned before, was also decisive for the achievement of projects of this latest era, such as the random membrane of 11 centimeters in thickness of the Maritime Avenue in Benidorm, or the structural sophistication of the roof and the double facade of the Zaragoza station. One of the engineers who has most deeply thought about these issues is Cécile Balmont, who was trained in England and a regular collaborator of architects such as Rem Koolhaas, Toyo Ito, and Álvaro Uziza. I met him and I talked to him extensively when he sponsored a class of architects at the International University. Balmont, author of publications such as Informal or Element, and responsible for Arab in its latest phase, thought that only the union of engineering and architecture would be able to face the challenges of project and contemporary work. If we analyze one of his most modest works, the Serpentine Pavilion, together with Toyo Ito in London, we see that with a mathematical algorithm, they define the triangles that seem chaotic in the pavilion, and that you can compare with the other building 50 years before by Ove Arup and Lubetkin in the London Zoo. Regarding the structural concept, Cécile Balmont, in his publication Informal, defines the theoretical parameters of a new type of structural process. On object tends to disappear, on limits go away, and where there is no hierarchy but interdependence and geometry of complexity. And at the same time, I believe that he is claiming a greater role in the creative processes of the project. Let's consider which has to be the attitude and the framework to create a more fruitful relationship between both professions. Regarding the attitude, we can highlight that experimentation has been able to dynamize the collaborations between engineers and architects, a cooperation that perhaps was born in those Parisian ateliers des Beaux-Arts at the end of the 19th century, that then led to the Bauhaus spirit, and that was consolidated with the collective creation that then disseminated thanks to the Weimar School, thanks to Walter Gropius. The text of the scope of total architecture connecting with the maximum aspiration of engineer over Arup, placing emphasis on integration, and that can be also said about today. And if the union of science and knowledge through empirical experimentation has been a resource for architects and engineers that we have mentioned, it's also true that this knowledge has been conveyed to the university, because almost all of them have taught in class, with very worthwhile exceptions such as Peter Rice, Jean Prouvé, who told his friends, please let me die as an ignorant, because they didn't find the place in the class, and that should be food for thought for us. If Jean Prouvé looked at us now and looked at our Polytechnical University, I hope that he could change his mind. Many engineers and architects had identified university as a place of learning and creation of new ideas, and understanding it as the threshold bringing together both areas, intuition and knowledge. And we end as we began, placing emphasis on the collective nature of construction, which goes beyond synthesis of specialities. Architecture and engineers share in their action an intellectual substrate. To do is to think. Words of American social scientist Richard Sennett. And this is the meaning of these few words, and as a cross-sectional, a global gaze at our disciplines that can lead to a universal idea of university. And I hope that this course will be full of uncertainty, but also full of hope.